Hello everyone. In this presentation, we are going to discuss an important topic in concrete technology, exposure conditions of concrete structures as per IS 456-2000 and IS 10262. Before designing a concrete mix, first decision we must take is to identify the exposure condition of the structure. This is because the durability of the concrete depends not only on its strength but also on the environment in which it will serve throughout its life. According to IS 456-2000, exposure conditions are classified into five categories: mild, moderate, severe, very severe, and extreme. IS 10262 uses these classifications to determine the minimum cement content, maximum water cement ratio, and the minimum grade of concrete required for durable construction. The five major exposure categories as per IS 456 Table 3 are mild, moderate, severe, very severe, and extreme. In the case of mild, it is protected against weather or aggressive conditions. In the case of moderate, the structure is sheltered from severe rain, condensation, and non aggressive soil. Under severe conditions, the structure is exposed to severe rain, alternate wetting, drying, and coastal environment. Very severe conditions include seawater spray, corrosive fumes, aggressive subsoil conditions. And the extreme indicates tidal zone, direct contact with aggressive chemicals. Let us understand each exposure conditions in detail. First one is mild exposure. This applies to concrete that is protected from weather and aggressive environmental conditions. These structures are generally located indoors and are not exposed to rain, moisture, or coastal conditions. Examples include interior beams, columns, and slabs of residential and office buildings. Since the environment is not aggressive, the durability requirements are comparatively less demanding. So next one is moderate exposure. In this condition, concrete may be exposed to rain, condensation, or non-aggressive soil and groundwater. Although the environment is more severe than mild exposure, it is still not highly aggressive. Typical examples include foundations in normal soil, buried concrete structures, and sheltered coastal structures. The third category is severe exposure. Concrete under this condition experiences severe rain, repeated wetting and drying, coastal environments, or continuous immersion in seawater. Such conditions accelerate the corrosion of reinforcement and reduce the service life of the concrete if proper precautions are not taken. Examples include water retaining structures, bridge components in coastal regions, and marine structures that remain submerged in seawater. Next condition is very severe exposure condition. This includes structures exposed to seawater spray, corrosive industrial fumes, or aggressive groundwater and sulfate bearing soils. These conditions demand much higher durability because harmful chemicals can penetrate the concrete and attack both the cement paste and the reinforcing steel. Typical examples are marine structures above the tidal zone and foundations constructed in aggressive soils. The final category is extreme exposure. This is the most severe environmental condition. It includes concrete placed in the tidal zone where structures undergo continuous cycles of wetting and drying, or structures directly exposed to aggressive chemicals. Examples include tidal zone marine structures, chemical plants, and effluent treatment tanks. Concrete in these environments requires the highest level of durability protection. So let us see how these exposure conditions influence concrete mix design. As the severity of exposure increases, the minimum cement content increases, maximum water cement ratio decreases, minimum grade of concrete becomes higher. For example, mild exposure requires a minimum cement content of 300 kg per cubic meter, maximum water cement ratio of 0.55 and a minimum grade of M20. Moderate exposure requires M25 concrete with a maximum water cement ratio of 0.5. Severe exposure requires M30 grade concrete and a maximum water cement ratio of 0.45. Very severe exposure requires M35 grade concrete. Extreme exposure requires M40 grade concrete with a maximum water cement ratio of 0.4 and a minimum cement content of 360 kg per cubic meter. These limits are specified to ensure that concrete remains durable throughout its lifetime, even after under harsh environmental conditions. To conclude, selecting correct exposure condition is the first step in concrete mix design. It helps us to determine the appropriate cement content, water cement ratio, and concrete grade required to achieve durability. We should remember that durability is important as strength. Even if concrete is strong, it may fail prematurely if it is not designed for the environment in which it is used. Therefore, every concrete mix must satisfy both strength requirements as well as durability requirements specified in IS 456-2000 and IS 10262-2019. Thank you.